Hey everyone, and welcome to the channel. If you're currently studying automation, just landed your first job, or even if you've been in the field for a few years, I've got something for you. There are some critical lessons that no textbook, no university class, and no professor will ever teach you. These are the real-world insights that separate the average engineers from the ones who truly excel and understand how this industry actually works. So grab a coffee, get comfortable, and let's dive into the 10 things every single automation engineer should know before stepping into the real world. First up, and this one's a biggie, networking is now a fundamental part of automation. Gone are the days when we could just focus on our PLC and sensors in isolation. Today, everything is connected. We're talking controllers, HMIs, servers, and even the smallest field devices, all communicating over a network. This means you absolutely have to understand the basics of IP addressing, what VLANs are and why they matter, how to configure switches, and the role of firewalls. And let's not forget the industrial protocols that make it all happen, like Modbus, OPC, and Ethernet IP. The biggest mistake I see young engineers make is thinking, oh, that's an IT problem. It's not. My tip for you is to start treating the network as an integral part of your control system, not just some separate responsibility for the IT department. When you can troubleshoot a network issue just as confidently as you can troubleshoot a logic bug, you become infinitely more valuable. All right, number 2 on our list, documentation is just as important as your code. I know. Nobody gets into engineering because they love paperwork. But let me be clear. Good engineers don't just build systems. They document them meticulously. Things like P&IDs, loop drawings, I/O lists, and those FAT and SAT reports aren't just bureaucratic hurdles. They are your professional memory. They are the roadmap that explains what you built, why you built it that way, and how it's supposed to work. Imagine coming back to a project 2 years later or having someone else take it over. Without clear documentation, it's a nightmare. So here's a habit you need to build right now. Every single time you make a change, no matter how small, update the corresponding document immediately. It might feel like a chore in the moment, but trust me, you'll be saving your future self or a colleague hours, maybe even days, of pain and confusion. Let's move on to number 3, a principle that separates the amateurs from the true masters. Simplicity beats complexity every single time. Look, anyone can write 1,000 lines of convoluted, clever logic that works. Most of the time. It's tempting to show off your programming skills, but a truly great engineer can write simple, clear, and elegant logic that is rock solid and reliable. Remember, in an industrial environment, the plant floor values stability and predictability far more than it values sophistication. If your code is so complex that the on-site maintenance technician can't understand it at 3 a.m. during a shutdown, you haven't succeeded. You've created a liability. So my tip is this. Your goal isn't to impress other engineers with your genius. It's to build a system that is easy to understand, easy to troubleshoot, and easy to maintain for years to come. Clarity is the ultimate sign of professionalism. Number 4, and this is crucial for your career growth. Don't limit yourself to just one brand. Whether you start out with Allen Bradley, Siemens, Honeywell, or Schneider, it's easy to get comfortable in one ecosystem. But here's the secret. They all operate on the same fundamental control principles. The tools, the software, the terminology, those are just different wrappers. If you only know one platform, you're not just limiting your technical skills, you're limiting your career opportunities. The most sought-after engineers are the ones who can walk into a plant, see a different brand of PLC and say, okay, different interface, same logic. I can handle this. My advice, be vendor neutral. Focus on learning the fundamentals, things like PID control, state machines, and ladder logic principles. Once you master those, you can apply them to any platform, anywhere in the world. Next, at number 5, we have a topic that's more critical now than ever. Cybersecurity matters more than you think. For a long time, control systems were isolated, running on their own private networks. That's no longer true. As we connect everything to everything else, our systems are becoming targets for cyber attacks. This isn't fear-mongering. It's the reality of our industry. You need to understand concepts like network segmentation to isolate critical systems, the role of firewalls, the importance of software patching, and the basics of standards like IEC 62443. Thinking security is IT's job is a dangerous and outdated mindset. As an automation engineer, you are on the front lines of protecting critical infrastructure. So, my tip is to always design with safety and security in mind from day one, not just functionality. A system isn't truly functional if it's not secure. Coming in at number 6 is a skill that many engineers overlook. Your communication skills will set you apart. You can be an absolute wizard with code, a genius with instrumentation. But if you can't explain your ideas clearly to other people, your brilliance gets lost. You'll be working with operators, maintenance teams, project managers, and company leadership, all of whom speak a different language. Being able to translate complex technical concepts into simple, understandable terms is a superpower. It builds trust, gets your projects approved, and ensures that the systems you design are used correctly. My advice is to actively practice this. Try explaining a complex control strategy to a friend who isn't an engineer. If you can make them understand it, you're on the right track. Don't just be the engineer in the corner. Be the engineer who can lead the conversation. Number 7 is a simple rule that will save you from a world of pain. Always back up and version control your work. You will never, ever appreciate the value of a recent backup until you've accidentally deleted or corrupted a PLC program or an HMI configuration right before a critical plant startup. It's a heart-stopping moment that is completely avoidable. You need to establish a rigorous standard for how you name your files, where you store your backups, and how you track different versions of your code. Whether you use a formal system like Git or just a disciplined folder structure, the key is consistency. My golden rule is a simple 3-step process: change, test, and then backup. Make it a reflex. Do it every single time without fail. Your future self will thank you profusely. Let's talk about number 8. Learn from the field, not just from the screen. Real automation isn't designed and built in a quiet, air-conditioned office. It's born in the field, amidst noisy compressors, next to hot furnaces, and surrounded by complex webs of wiring and tubing. You will learn more about how a sensor really behaves, why a valve is sticking, or the nuances of a process by spending one day on site than you'll learn in a month of classroom theory. There's a texture, a reality to the physical world that you just can't get from a simulation. So my tip, especially for those early in their careers, is to spend as much time in the field as you possibly can. Put on your steel-toed boots, grab your hard hat, and go observe. Ask the operators and technicians questions. Listen to their experiences. That's where the real education happens. Number 9 is all about the people. Build a strong professional network. The best jobs, the most exciting opportunities, and the most valuable insights often don't come from online job portals. They come from the people you know. Your network is your career safety net and your growth accelerator. Connecting with your peers, attending industry events and trade shows, and joining online communities can dramatically speed up your learning curve. Don't be a passive observer. Be active on platforms like LinkedIn. Join automation-focused groups on Reddit or Facebook. Share what you're working on. Ask thoughtful questions, and don't be afraid to offer help to others. every connection you make is a potential mentor, collaborator, or future employer. The automation community is smaller than you think, and a good reputation travels fast. Finally, number 10, and perhaps the most important lesson of all, take care of your work-life balance. Automation projects can be incredibly intense. We face tight deadlines, long hours, high-pressure plant shutdowns, and on-call schedules. It's easy to get consumed by the work, but if you don't proactively take care of your physical health and your mental well-being, burnout is not a possibility. It's an inevitability. Remember that rest is not a luxury. It's a critical part of being effective. Continue to learn and grow outside of your immediate projects. And most importantly, remember that being a great engineer means being a healthy, balanced human being first. Your career is a marathon, not a sprint. Don't burn out in the first few miles. So there you have it, 10 crucial lessons they don't teach you in engineering school. Automation is an absolutely incredible career. It's this amazing blend of logic, hardware, and pure creativity, unlike almost any other field. But the real deep learning truly begins the day after you graduate. If you can master these 10 lessons early in your career, you won't just be another automation engineer, you'll be a highly respected, sought-after professional who truly makes a difference. Thanks so much for watching. If you found this advice helpful, do me a favor and hit that like button. And consider subscribing for more real-world engineering advice they never taught us in school. I'll see you in the next one.